In this video clip, I'm going to explain part 4 and part 5 of problem 2 in homework number 1. In the previous video clip, I explained part 1, 2, 3 of problem 2. Now, I'm going to actually explain how to do problem or part 4 and part 5. So in part 4, you are asked to do or asked to find x such that norm of ax is smaller than x. To do that, well, I'm going to show you a very simple way. Let's look at the problem when n is equal to 5. Okay, so I'm going to print out the form of a when n is equal to 5. Okay, so let me do that. So here is how a looks like, which is 1 on the diagonal and -1 on the upper triangular part of the matrix. Now, we're looking for x such that norm of ax, basically we're looking for x, so let me write it down here. We're looking for x such that norm of a times x is less than norm of x. Okay, let's multiply a by a guess vector of x. So here is my guess vector. I do 1, 1/2, 1/4, 1/8, 1/16. And you may ask how I came up with this guess is because if you multiply a by x, you see that the first element would be something like, so if you multiply a by x, okay, now if I call, let's consider x as x1 and x2 and x3 and x4 and x5, okay, then a times x would look something like x1 minus x2 minus x3 minus x4 minus x5. So this is the first element. The second element of x would be x2 minus x3 minus x4 minus x5. And the next one would be x3 minus x4 minus x5 and so forth, right? So don't do the rest. I guess you can easily do element 4 and 5. Now, I want this vector, right? Norm of this vector to be less than norm of that. So an easy try would be, what if I make each element, like element 1 to be less than x1, and element 2 to be less than x2, and then element 3 to be less than x3, and so forth, right? Okay, so now if all x1 and x2 and x3, x4, 5, all of them are positive, you can easily, by looking at inverse of a, you can actually guess that, this thing would work. Okay, so let me do a inverse. So this is a inverse. Basically, the vector I'm looking at is inverse of the last column, or the reciprocal of the last column. Okay, so that would look something like this. Now let's do that. Let's do the math. Let's multiply a by x and see how it looks like. Okay, so let me do that. Okay, so here's our x, right? This is my guess. And then when you multiply a by x, this is what you get. And each element of this, each element of y is less than or equal to element of x. Now, if you get the norm of x, right? Let's do norm x1. Well, it's sum of the elements, right? And then if you do norm y, norm 1, you see that it's much smaller than that, okay? Basically, when you do norm 1, if you remember from class discussion, norm 1 is sum of the absolute value of the elements, and sum of these would be definitely sum of these because each element in y is less than each element in x, corresponding element in x, right? Anyways, so here's the guess, which actually solves part 4 of problem 2. Now, part 5 is, well, it says because the matrix is already upper triangular, Gaussian elimination with partial pivoting has no work to do. And this is correct because when you look at the matrix A, right, so here's matrix A, it has all ones on the diagonal and then it's 0 below the diagonal. Okay, so it's already upper diagonal, and for Gaussian elimination you can easily start from the last row and do back substitution. Okay, now because of that, Gaussian elimination has no work to do. The question is, what are the pivots? Well, pivots are actually the elements on the diagonal, which is in this case all ones. Alright, so hopefully this solves part 4 and part 5 of problem 2 and homework 1.